Sir, has the session started?
Hello everyone. Am I audible?
Yes, ma'am.
Okay, so have you all seen the lectures of week 2?
Yes, ma'am.
Okay, so we will solve questions based on week 2 topics. My screen is visible, right?
Yes, ma'am.
Okay, so what topics you have studied in week 2? Anyone who have seen the lectures?
What's your question, ma'am?
So whatever things you have studied, just tell me in week 2. Has anyone seen the lectures?
Maximum and minimum of a function.
Okay,
Functions of random variables.
yes. Okay, so the very
IID.
first topic is the independence.
Yes.
So majorly two topics are there: independence of random variable and functions of random variable. So I'm just writing the things. So independence of random variable. So if we have two random variables, suppose x and y. Okay, so let x and y are two random variables. Okay, then they will be independent of each other. In which condition? What is the condition for independence?
The joint PMF should be the product of marginal PMF.
Yeah. So their joint probability, joint PMF, should be equal to the product of their marginal, right? So let x and y be two random variable, and they will be independent. Independent if their joint probability is equal to the product of their marginal. Okay, and this should be true for all t1 belongs to tx. Okay, which means that x is taking this t1 is taking value in the range of x, and this t2 will belong in the range of y. Okay, so this is for two random variable. What if you have multiple random variables? Then same condition would be applied there also. So if you
Right.
have, suppose n random variables, x1, if x1, x2 up to xn are independent, okay, then fx1, x2 up to xn, okay, this should be equal to their product of their marginal.
Excuse me, ma'am.
Yes.
In the case of multiple random variables, shouldn't we have to check pairwise also?
So the thing is that set of different variables should be independent. So basically, we have to check. So first of all, we say all of them x1, x2, xn are independent when their joint is equal to the product of their marginal, which is
I could
simply
not
this
understand,
condition.
ma'am. Because when we basically learned about the independence in terms of events, then we basically learned that we also have to check for pairwise also, actually.
Yes.
Then why not here? Like this condition for all plus pairwise comparison of all.
So the thing is, if x1, x2 up to xn are independent, then they are like set. If we create the set of, suppose if we are taking x1 and x2, then they will also be independent. Okay, so out of these n random variables, if we create set of few of the random variables, then they will also be independent. This is the condition.
So here it's not necessary to check pairwise also. It's this one condition is sufficient.
Yes.
Okay.
Ma'am, mutual independence implies pairwise independence. Is it true?
Can you please repeat?
Ma'am, mutual independence implies pairwise independence.
See, we are saying that if these n independent random variables are independent, and then if we take set from these random variables, then they will be independent. But if you are saying that x1, x2 are independent with other, and you are merging them all, then we cannot say that all the random variables will be independent. Are you getting my point?
Okay,
Yes,
ma'am.
ma'am.
So basically, all the subsets from these n random variables will also be independent if these n random variables are independent in that case. Okay, so this is for independence. Next is, what do you understand by IID random variables? What do you mean by IID?
Independence and identically distributed.
Independent and identical.
Yes, so independent and identically distributed. So basically, it means that if you have n random variables which are IID, so they all will be independent with each other, and they will also be following the same distribution. Okay, this is the meaning of IID. And one more thing you have studied in this week, which is the memoryless property. So what is the memoryless property of geometric distribution? Anyone? What do you understand by it?
Probability of m plus n greater than z conditioned n greater than z is equal to probability of n greater than z.
So suppose if we have a random variable x which is following geometric distribution, okay, with suppose parameter p, then there are two things. So the thing is that x is greater than m plus n, given that x is greater than m. Okay, so this value should be equal to what? Probability x is greater than m. Okay, and when you calculate, I'm not going to solve the proof. So this value should be equal to 1 minus p to the power n. So what is the meaning of this memoryless property is, okay, first of all, what is the geometric distribution? What do you understand by geometric distribution? In which scenario we use this?
And like probability of first hit.
Yeah, so geometric distribution basically tells you the number of trials required to get your first success. Okay, so it is saying that if I take an example, if you are tossing a coin, okay, suppose 1,000 times. So basically, in your experiment, you will toss your coin until you get your first head. Okay, so in geometric distribution, we do not fix the number of trials earlier, as we do in binomial distribution. Okay, we repeat our experiment until we get our first head. Okay, so the experiment is we are just tossing a coin, and the success will be, if you are getting a head, then we are considering it as a success. So we are saying that suppose we have tossed our coin 1,000 times, okay, and we have not received our success, which means we have not received any head in the 1,000 trials. Suppose so x is greater than 1,000. Okay, now we are saying, after doing the 1,000 trials, now we are saying that what is the probability that we have to toss it for next 50 times. So this probability, according to this formula, this should be equal to x greater than what?
50.
50. Which means if you are just starting your experiment and you are saying that you will have to repeat your experiment 50 times for getting a success, for getting a head. It is same as when you already have tossed your coin 1,000 times, and then you are saying that we still require 50 more trials to get our first success.
The previous trials has no value.
Yes, so it does not depends on the previous trial. That's why it is called memoryless. Okay, so
Yes.
you can.
And probability of x greater than should be 1 minus p to the power n minus 1 into p to the power n.
Sorry.
No, that is when x is equal
That
to
is
n.
binomial, right? It's binomial.
Sorry, I did not understand your question.
No, doesn't we do that when we are trying to achieve something after multiple trials of failure? In your earlier session, I think binomial, when you covered, you mentioned that it is binomial. NCR
So binomial and geometric are different.
Yeah, this binomial not applicable here. Yeah.
Yeah, it is not for binomial distribution. Okay, it is for geometric distribution.
Ma'am, what is the formula for geometric distribution?
So if x is following geometric, then this PMF the probability that x is taking value k. Okay, so what does it mean? We need k trials, okay,
To get the success.
to get the first success. So this will be 1 minus p to the power k minus 1, which means until k minus 1 trials you are getting your failure, and then at kth trial you are getting your success. And here k will be taking values 1, 2, 3 and so on. So this is the PMF for geometric distribution. So I hope you can solve this probability x is greater than n. So what you have to do, you have to take the summation over the PMF and the range will start from n. N plus 1, because it is a discrete distribution. So range will start from n plus 1 and will go up to infinity, and you solve, you will get 1 minus p to the power n. Okay, so this is our neighborhoodness property for geometric distribution. Okay, and now, is it clear to everyone?
Yes, ma'am.
But if we start from n plus 1,
Second
then
point.
k is equal to n, no, madam? That means k is equal to n, you are saying. K equal to n plus 1, right? In this formula.
See, this is like x is greater than n, okay? So you have to add all those cases where x is taking values greater than n. So which means x is equals to k, this is the formula. So you will have to add all these probabilities. You have to take summation over this PMF. Okay, and you can see that k will start from n plus 1 and will go up to infinity. And now you have to put the value of the PMF. Okay. And then we have the next thing. Sum of two independent Poisson variables. So suppose we have a random variable x which is following Poisson distribution, and it is following Poisson with parameter lambda 1, suppose. And we have another random variable y which is following Poisson distribution with parameter lambda 2. Then now we are defining another random variable z which is equals to x plus y. Then can you tell me what will be the distribution of z?
Poisson with lambda 1 plus lambda 2.
Yeah.
Yeah. So z will be following Poisson distribution with parameter lambda 1 plus lambda 2. Okay. Similarly, what will be the distribution for x given z or y given z?
Binomial.
So it will be binomial. So x given z, okay, that will, z is equals to n. So that will follow binomial distribution. And what will be the parameters?
N comma lambda 1 by lambda 1 plus lambda 2.
Yeah. So parameter n, and the probability of success will be 1 divided by lambda 1 plus lambda 2. Similarly for y given z, so that will be binomial.
N comma lambda 2 by lambda 1 plus lambda 2.
Okay, is it clear to everyone?
मैम ये प्रोबेबिलिटी वाला पार्ट नहीं क्लियर हो रहा.
Which probability part?
In binomial.
This one?
Yes.
So actually the thing is, when you try to find out this probability, x given z. Okay, I'm not going to prove it. If you have seen the lecture, then you will be able to understand this.
और मैम ये भी कंफ्यूजन है कि पॉइजन से बाइनोमियल में क्यों यहाँ पे डाइवर्ट हुआ, यहाँ पे क्यों आ गया?
Yes, so when you try to calculate this part, x is equals to k, suppose, given that z is equals to n. Basically, you have to calculate this probability. Okay, and you will see that this PMF will be in the format of binomial PMF with these parameters. Okay, so then we can say that this probability distribution will be following the binomial distribution. Okay, so when you solve it, then you will be able to understand. Okay, so
मैम इनके बीच का इंटररिलेशन क्या है? इंटरकनेक्शन.
see, the thing is, this is the formula like PMF of binomial, okay? N C x p to the power x 1 minus p to the power n minus x, right? So when you calculate this probability, x given k, x is equals to k given z is equals to n, you will get this probability, it will be in this format. But in the place of n will be n only, but the probability of success p, okay, this p will be equal to lambda 1 divided by lambda 1 plus lambda 2. So from here we can say that it is following binomial distribution with parameter n comma lambda 1 divided by lambda 1 plus lambda 2. From there you will get this relation.
Okay.
Okay.
Ma'am, this n is constant, is it? Like we will be given that n because when
Yes,
the
the
Poisson
value of z will be given.
okay.
Okay,
Okay.
because it is one of the
Because
value of z actually.
okay, because there was some formula even for the n as well, right? When the Poisson distributions used to happen. That's why I was asking.
For n.
Yeah, I mean there was something like e to the power minus lambda into lambda to the power n.
That's what I'm saying, that when you solve it, you will get the PMF in this format, which is the formula of PMF of binomial. But the change will be like the probability of success will be lambda 1 divided by lambda 1 plus lambda 2.
Okay.
So at the place of p, you will get this value.
Okay.
Okay, it will be similar to that. And for Poisson distribution, the PMF is e to the power minus lambda, lambda to the power x divided by x factorial.
Okay, only when the
So if
conditional
you,
then it becomes
I
binomial.
think you are saying about the PMF of Z. So Z is following lambda 1 plus lambda 2 Poisson. So there you will get e to the power minus lambda 1 plus lambda 2.
Okay.
That PMF, okay?
Okay, so individual PMFs are following that Poisson formula, correct?
Yes.
Individual PMF, but
Yes.
conditional PMF in this case is following binomial. Okay.
Yes.
Can you please scroll down a little bit? A little more, please. Yes, done.
Okay, so now we will solve the questions. So this is your first question. The joint PMF of two discrete random variables x and y is given. Now you have to check whether x and y are independent or not. So try to solve it. So what thing we have to check? What is the condition to check this question?
Joint probability equal to product of
Marginal
marginal.
probability of x is into marginal probability of y is equal to joint.
Yes. So for this particular value, what product I have to check?
0.30 into a.
Yeah. So this should be equal to the product of 0.30 and a. So first of all, we have to calculate these values a and b, right? So what will be the value of a and b?
And the value of a is 0.60
Equal to 18 into 3. 0.18 into 1.
So a will be equal to 0.6 and b
0.16. 0.16, yeah.
b will be equal to 0.16. Now you have to check. Okay, so this 0.18 should be equal to 0.30 into 0.6, which is true, right? Now next is this one, 0.24. So this should be equal to 0.40 into 0.6, which is again true, right?
Yes.
Next we have to check for this. So 0.6 into 0.3, which is again true. Okay, so same things we have to check for each case. For each joint probability, we have to check whether it is equal to the product of marginal or not. So if the condition satisfies for all the cases, then only we can say that x and y are independent. If suppose for this case it is not equal to the product of marginal, if in case, then x and y will not be independent. Okay, so the condition should be satisfied for all the cases. So here you can see all the cases.
Ma'am, is there any easier or an alternative method for this? Because for 6 values, we have to check one by one.
This is the only method you can check. The product, the joint should be equal to the product of marginal. In the exam, you will not be given so many values to check. Okay. So this question is clear to everyone?
Yes, ma'am.
Yes, ma'am.
Okay, so here we can say that x and y are independent. Now this is your next question. So here again, x and y be independent discrete random variables. Such
Ma'am,
that
0.05 should be the answer because the conditional is equal to the marginal.
yes, correct. So because x and y are independent, so in that case, the conditional distribution of y given x will be equal to the marginal of y. Right? So from here we can directly say that the marginal of y will be equal to 0.05. Okay, so y given x is equals to t1.
Conditional is equal to unconditional, ma'am.
Yes, so this will be equal to the unconditional probability of y. Okay, as x and y are independent. So from here you can directly say that the marginal of y is equal to 0.05. Or you can use the formula of conditional probability, which is y given x is equals to t1, t2. So if I open the conditional formula, it will be the joint of x and y divided by the marginal of x. Right? So here this conditional probability is given, which is 0.05. Then joint divided by marginal of x is also given, which is 0.4. Okay, so this is 0.4. From here we can find the joint. So that will be equal to 0.05 into 0.4, which is 0.02. And now we know that x and y are independent, so this joint we can write it as the product of marginal.
0.20, no, ma'am.
It should be 0.02, right?
Yes.
Okay. So this is 0.02. Now we will put the value of this, the PMF of x, which is 0.4, right? Into marginal of y. So from here also you can get the value of
0.05.
Okay, so it will be 0.05. Okay. Is this question clear?
Yes.
Okay, now try to solve this one.
मैम कैसे 0.05 मैम क्लियर नहीं हुआ लास्ट है.
Okay, so until this point is it clear?
Yeah.
Okay, then we have to use the condition for independence. So joint should be equal to the product of marginal.
Yes.
Okay, so in place of joint, I have written this thing. Okay, then we know the value of marginal of x.
Yes.
You can see it is given
0.4.
here.
Yeah.
So I just have put the value. This is not x, this is the multiplication sign. Okay, don't get confused with it. Okay, and then from here it is simple. It would be 0.02 divided by 0.4 simply.
Ma'am, please explain first part where you get 0.05.
So whenever x and y are independent. Okay, so whenever two variables are independent, in that case the conditional PMF, okay, is equal to the unconditional PMF of that variable.
Yes, ma'am, got it.
Okay, so the PMF for y given x, okay, this probability will be equal to the probability of y, okay, marginal probability of y.
Okay, ma'am.
Okay, so from here we can directly find this value, and this value is given to us in the question.
Yes.
Okay, now is it clear?
Yeah, ma'am,
Now,
clear.
one basic question, ma'am. Like this, when we claim actually it is independent, then like x equal to t1, that already that condition given, right? So that means there is a condition implicit, right? How can we say it is independent?
See, the condition is given, that is okay, but x and y are independent. Okay, so this probability will not be affected by this condition.
Yes.
Okay, that's why the conditional probability will be equal to the unconditional probability if the variables are independent.
Yes,
Though
ma'am.
the condition that event has happened, as actually things are independent, we are actually ignoring that condition, right?
Yes, because they are independent, that's why.
They are independent.
Okay, and when they are independent, then only this condition will be true, not in all the cases. Okay. Now this step is clear?
Yeah.
Yes, ma'am.
Yes.
Now try to solve this one.
One-eighth.
Okay, so in this question, it is given that a fair coin is tossed. A fair coin is tossed.
Ma'am, 1/4.
Okay, we'll see. Then let the discrete random variable x denote the number of tosses required to get the first head. So we can easily guess what will be the distribution of x here.
Geometry.
Geometric, right? Geometric, right? The question is.
Ma'am, memory list.
Question is what? Yes, we have to use memory list property here. So here we can say that x is following geometric distribution. And what will be the value of the parameter?
Half.
Half, because we have fair coin. So the probability of getting a head will be 1/2. Is it clear?
Yes.
Okay, so that's why the value of P, the probability of success will be 1/2. Okay, now we have to find this probability that x is, what is the probability that the first head appears after the fifth toss,
Greater than 5.
which means x is greater than 5, given that the first 3 tosses were tails. So first 3 tosses were tails, which means it is a failure.
Yes.
Okay, so again the first head, which means x should be greater than 3,
Yes.
right? Because in the first 3 tosses we have not received the success. Okay, so this is something we have to calculate. So here you have two ways to solve this question. Either you can follow the simple conditional formula, conditional probability, or you can use the memoryless property. Okay, so I can write it as that x is greater than 2 plus
3 + 2.
2 plus 3, given that x is greater than 3. So now can you identify it will be equal to which probability?
X greater than 2.
X greater than 2. Okay, so simply we have to calculate the probability x is greater than 2. So now if you remember the formula of it, okay, that I have written earlier, it is this one. Okay, when x is greater than n, then it is equal to 1 minus p to the power n. Okay, so we can just directly put the values. So here it will be 1 minus p to the power 2. Okay, here value of n is 2. Is it clear?
Yes, ma'am.
Okay, or if in case you don't remember the formula, so
Why is the x value is 1?
so this is one way. If you remember all the formulas, you can directly put the values. Or if you don't remember what is the value of x is greater than n, what is the probability x is greater than n, then what you can do, you can simply calculate it by using the properties. So it will be 1 minus p, 1 minus probability x is less than or equal to 2, right?
Yes.
So 1 minus, this is nothing but x is equals to 1 plus x is equal to 2. So always remember that if you are using the PMF of geometric distribution, the value of x starts with 1,
Okay.
not with 0. Okay?
Yes.
Because what does x represent is, x is representing the number of trials. So x can never be 0, right? At least one trial you will have in your experiment. Okay, so value of x will start with 1. Now you can just simply put the value in the PMF. So this will be 1 minus p to the power 1 minus 1, right? Into 2. Plus this will be 1 minus p to the power 2 minus 1 into p. So this will become 0, 1 minus p to the power 0, which is 1. Okay, so simply p, and this will be 1 minus p to the power 1, and this p.
मैम 1 और 2 में से 1 ही क्यों घटा रहे हैं हम?
See, this is the formula. This is the PMF. 1 minute, I will show you only. This is the PMF. It is in the formula that k minus 1 should be there in the power of 1 minus p.
Clear.
Okay, that's why we are subtracting 1.
Sorry, ma'am.
Okay, so we can solve it. 1 minus, you can take p as common, so it will be 1 plus 1 minus p. Okay, so 1 minus 2p plus p square, right? Which is again 1 minus p whole square,
Yes.
right? Now you just put the value of p. Okay, it will be equal to 1 by 4.
One question, ma'am. Could you please go up a little bit? Here, x greater than 3. So, depending on the condition, like okay, we have coined because tails is the one actually considered. So, the more than 3 trials, okay, or more than 3 times when we tried, toss appeared, right? So that's why we found this x greater than 3. if in this case instead of tails, first case is tails and second is head, then it cannot be x is greater than 3, right? It should be, there should be a new
Yes.
variable to be introduced, y, right?
Not new variable, then in that case it will be x is greater than 1, because in the second toss itself you are getting the head, right? You are saying in the first toss we are getting tail, in the second toss we are getting head,
Yeah.
which means in the second toss only we are getting the success.
No, what I'm saying is, here it is given as a fifth toss, and then the third toss, right? These three are the things given. Okay, let actually the first one be fifth toss. The second one, if it is 3, instead of 3 tosses, if it is 3 tails, 3 heads, okay, then how can we frame that in this? The
So
probability.
can you repeat the last line?
Instead of 3 tosses, if it is 3 okay, tosses, right? Okay, got it. Yeah, 3 tosses were tails. Yeah. Okay. In the here, 3 tosses were tails, right? Instead of that, if it is 3 tosses were heads, will it come like that? Because the first one is dependent on the tails, second one is dependent on the head. That never be the case, right?
See, you have to figure it out what information is given. So you are saying that the experiment is we are tossing the fair coin until the first head appears. So we are taking head as our success.
Yes.
So it may vary. You can take head as success, or you can take tail as a success also. So here we are considering that if we get head, then it is a success for us. Okay, so which means in the first 3 tosses we are getting tail, which means we are getting failure.
Yes.
If you are getting head in the first tosses, then the question will not be like this, because we have already received our success.
Yes.
Okay, then the question will be different.
Yeah, got it. Thanks.
Ma'am, one question, small question. Actually, this is asked in one of the practice assignments. That is, if there are 2 players, say P and Q, tossing a coin, so you have to strike 3 heads in order to win the game. So, what is the probability that the second player wins in the 5th toss? How will I do this?
Okay, we will see these type of questions in the doubt session. I have to see the question first. Is it in the practice assignment, or you're asking it from the GA?
No. It is in the practice assignment only, week one somewhere.
In week 1? So week
Yes.
1 will not contain these topics?
But it had this one.
Can you repeat the question again?
2 players, say P and Q, were tossing a coin in order to win the game. So, if you have 3 heads, then you win the game. So, what is the probability of the second player winning the game at the 5th toss?
Okay, that is not based on these topics, I guess. Is it not? I think it's not in the week 1. Okay, I'll see this question when it comes in the doubt session.
Okay.
Okay, is there any question from this question?
Can you show this slide?
Which part?
This part only. X is greater than 1. I'm down now.
This or
Yes, X is greater than 2.
X is greater than 2. Any other question? Okay, then let's move on to the next question. So here x be a discrete random variable with this PMF. Okay, and we are given a new random variable, this. So here y is actually the function of random variable x. So now we have to find the range of phi, then we have to find the probability mass function of phi. Try to solve it.
Ma'am, range is 0, 2, and 6.
Okay. So the values of x are -2, -1, 0, 1, and 2. And y is defined as x, x plus 1. Okay. So when you put the values, it is nothing but x square plus x, right? So it will be 4 plus 4 minus 2, which is 2. Then this will be 0, 0, 2, 6. Right? So from here you can see the range of y, okay, that will be 0, 2, and 6. Is it clear?
Yes, ma'am.
Okay, now we have to find the PMF of z. So basically we have to find the probabilities for the y taking value 0, 2, and 6. So you can see that how can we calculate probability y taking value 0 is, so y is 0 when x is equals to -1 and x is equals to 0, right? So we just have to add these two probabilities. So when x is equals to -1, x is equals to 0, right? Now we just have to write the probabilities when x is equals to -1 and 0. So x is equals to -1, it is 0.2, and when it is 0, it is 0.3. So it is 0.2 plus 0.3, which is equals to 0.5.
Ma'am, why we are adding the probabilities of x in this case? Means I basically want to ask that why we are using the reference of x to calculate the probability of y.
Yeah, see, y is the function of x only, so, which means y is dependent on x. Okay,
Yeah,
so the
that's
values,
clear.
values of y are decided by x only. So it is simply you have to add the probabilities for different cases, because in these two cases y is taking value 0. So you have to add all those cases when y is becoming 0.
Okay.
And already we know the PMF of x. So we can simply find the probabilities of x.
Okay.
Now the next is we have to find when y is taking value 2. So again we will consider all the cases of y is equals to 2. Okay, so we have to add
-2 and 1.
we have to add, yeah. So we have to take x is equals to -2 and x is equals to 1. Okay. So x is equals to -2 and then x is equals to 1. So x is equals to -2 is 0.1 and at 1 it is 0.2. 0.1 plus 0.2, which will be 0.3. Okay, now next and last is when y is equals to 6. So only one case is there when y is 6, when x is equals to 2. Okay. So probability x is equals to 2, which is equal to 0.2. Okay. So be 0.2. Okay, now we can write the KMF of y. So y is taking that 0, 2 and 6 with probabilities 0.5, 3 and 2. So it is 0.5, 0.3 and 0.2. Is it clear to everyone now?
Yes.
Yes, ma'am.
Okay, now this is the next question based on the same topic.
Ma'am, can we say that any random variable, any function from a random variable to real number is also a random variable?
Any function?
Any function from a random variable to real number. Can that will also be a real random variable? Just say, as we can see here, x square plus x taking values from x, and also y working as a random variable.
Yeah, see, y is also a random variable here. Okay, so function of a random variable will also be a random variable. So here
Yes,
x and y both are random variable.
yes, ma'am.
Ma'am, one small question. It's a doubt that exactly what do we mean by a random variable?
You have not studied what is a random variable yet?
No, I have studied, but please explain in one or two sentences. Just
Okay,
हम
so
आगे
for
बढ़ते बढ़ते थोड़ा सा कंफ्यूजन हो जाता है.
It's a numerical value attached to a outcome, basically.
We explain now.
okay, see, whenever you have a random experiment, so what do you understand by random experiment first? So random experiment is a kind of experiment where you know the possible outcomes, but we don't know what exact outcome you will get. Okay, now
Yes.
what we will do for the outcomes we are getting, we assign numerical values. Okay, so for each outcome we assign some numerical values that we say as a random variable.
okay. Thank you.
So random variable is always associated with some random experiment, and based on the outcome we define a random variable.
As head is 0 and tail is 1.
Yes. Okay, try to solve this one. So here x is following uniform -5 -4 up to 4 5, and this is the function we are defined here. So first of all, we will write all the values taken by x. So it is -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, and 5. Now we have to write the values of y or fx. Y and fx both are same. Okay. So y is nothing but the function of x, so that's why it is written like this. And we have to find the distribution of y. So what will be the values of y? How we will decide?
Ma'am, it's what's it given? It's basically the function, or it's basically given the probability.
See, it is given the value. Okay.
Notation is kind of confusing. That's what I'm saying.
So for all less than zeros,
Okay.
y will take
If you
value
are
0.
getting with this, okay. See, you might be understanding it as the PMF of x.
Yes.
Okay. If you are getting confused with it, then don't consider it as fx. So why it is written as fx? Because it is a function of y. But okay, you just think it like this. So y is x when x is greater than 0. Otherwise, it is 0. So what do you understand by it?
For all negative x,
जब तक
we need to
जीरो
put
से बड़ा
0.
रहेगा x की
For
सेम वैल्यू
-4, -3, everything 0.
Yes. So when x is greater than 0, so this x, okay, these values. So when these values are greater than 0, it is same as that value. Okay. So x is greater than 0, which means 1, 2, 3, 4, and 5. It is same as x, which means 1, 2, 3, 4, and 5. Okay. Now is it clear?
Yes.
Also value
And 0 otherwise. So for all the other cases, it will be 0. 0 for all the other values.
This will be the range of y.
Yeah, these are the values of y or range of y. Okay, now we have to find the probabilities. So we can see that y takes values 0, 1, 2, 3, 4, and 5. Okay. Now according to the PMF of x, we need to calculate the probabilities for y.
Probabilities for y. Ma'am, for 0 it will be 6 by 11.
Yes.
Yes, it will be 6 by 11. Why? Because you can see that for all the cases from -5, -4, -3, -2, -1, and 0.
It's 1 by 11 for everyone.
Yeah, so for every for each case, the probability will be 1 by 11. Okay, because you can see 11 values are there, right? And it is a uniform distribution, so the probability will be 1 by 11 for each case, right? For each case, we have 1 by 11, and we are getting 6 times 0.
0.
So when you add all the cases, it will become 6 by 11.
And 1 by 11 for rest of other values of y.
Yes, so rest of the cases, it will be 1 by 6. Oh, sorry, 1 by 11. So I am writing it. So y is equals to 0, which means what we have to do? We have to add x is equals to -5 plus x should be equals to -4, and up to where we have to take it -5, -4, -3, -2, -1, and 0. Okay, I'm not writing all the cases. I hope you will be able to understand it. So 1 by 11 plus 1 by 11. Okay, so this will be 6 times, right?
Yes.
So this will be 6 by 11. Okay.
It's equal to 0 will not come there. Because greater than 0 only should come. No, correct. Yes.
Is it correct?
Yeah, it's correct. Yeah, please proceed.
Okay. Because for x is greater than 0, it is x.
It's y equal to 0, right? So it should be fine.
Yes. Okay. Because for y 0, x is 0 here also. And now for rest of the cases, for y is equal
1 by 11.
For y is equals. Yeah. So when y is equals to 1, this is equals to y is equals to 2. I'm just writing it so that no one get confused how we have calculated it. all these probabilities will be equals to will be same. And will be equal to 1 by 11. Okay. So if you write the PMF of y, it will be 0 and then 1, 2, 3, 4 and 5. So this will be 6 by 11. And the others are 1 by 11. Okay. And now if you want to check whether y, the PMF of y is valid or not, whether y is a random variable or not, you can check the condition for a valid PMF that all the probabilities should be greater than or equal to 0. Okay, which is true here. And when you add all the probabilities, it should be equal to 1. So you can check this is 6, 7, 8, 9, 10, 11. So 11 by 11 will be 1. So from here you can see that y is also a random variable. Okay, with a valid PMF.
Yeah, ma'am.
Okay, should I move on to the next question?
Yeah.
Yes.
This one. So here you are given x and y, which are two independent random variables. Okay, and their PMFs are given. Then we are defining a new random variable z as x plus y, and we have to find this value.
Range of x and y is same in this question. It's not one.
Yes, it is same. Both the PMF for both x and y are same, and the range is also
No, range is also same, no?
yeah, range is also same.
Okay.
You will be the one continuing for all TA sessions for stats, no?
Sorry, what?
For all future TA sessions. This is a TA session, right?
It is not
It's an instructor session.
Instructor session. Okay.
Yes.
But I think last time I attended, not sure whether that is instructor or TA session.
So on Sunday and Tuesday we have instructor session, and on the other days we have TA sessions.
So you are handling TA also, right?
No, I am not handling TA. TAs are different.
Ma'am, answer is 1 by 3.
Okay, let's see it. So we have to find fz 3, okay, which means the probability of z equals to 3. Okay, this is something we have to find, right?
Yes.
Yes.
Now z we can write x plus y. So x plus y is equals to 3. Okay. Now you can see that x and y are discrete random variables. So we have to see in what cases x plus y will be equal to 3. So this kind of question we have solved in week 1 also.
1, 2, 2, 1.
So when x is equals to 1 and y is equals to 2, right?
Yes.
Or when x is equals to 2 and y is equals to 1, right? So these two cases will be there only.
Yes.
Yeah.
Okay. If there is 0 also included, then we can say that x0 and y2 and y0 x2, but 0 is not here. Only these two cases. Now we know that x and y are independent. Okay. So the joint can be written as the product of marginal. Right?
Yes, ma'am.
And now we know the marginals of x and y. So we can simply use the PMF. Okay, so the PMF is 1 by 6 when k is taking values 1, 2, 3, 4, 5 and 6. So you can see that we have to find the PMF at point 1 and 2. Right? So This will be equal to 1 by 6 only.
1 by 6.
So this is 1 by 6. This is also 1 by 6. Okay.
1 by 16.
By 16.
No, 1 by 18.
2 by 36, which is 1 by 18.
Sorry, 1 by 18.
Is it clear to everyone?
Yes.
Ma'am, why are we not taking 0 case if x is equal to 0 or y equal to 0?
Yes. So here in the range, you have to see which values are taken by y and x. So you can see 0 is not there.
Ma'am, otherwise case.
So in otherwise case, it will be 0, no? The probability will be 0.
Yes,
And
ma'am.
if
Yes.
x and y are 0, then the summation cannot be 3. Because actually x and y are not taking values 0. We have to take only those cases when x plus y will be equal to 3.
Plus y will be equal to
Here 0 is probability, not random variable.
Yeah, this is the probability, or we can say PMF.
Here, by finding the joint PMF, P of x equal to 1 and y equal to 2, okay, we are considering these are two marginal independent things, so two marginal product that we are taking. But somewhere actually we are, for some other scenario, we are adding, right? Earlier you mentioned we are adding.
See, why I have written this joint as the product of marginal? Because x and y are independent.
Yeah, but the probabilities when we consider for a conditional somewhere, okay, we added two values. For example, x equal to 1 and y equal to 2, right?
Yeah, that was actually a different kind of question. And there x and y were not independent, and we were given the joint probability. So that's why we were doing the question in that way. But here you can see that joint is not given to us.
Oh, okay. We are not given with these values now.
And we can simply find the joint by taking the product of marginal.
Yeah, earlier I think we are given with the table, so we just picked it
Yes.
directly.
Yeah, so that was the joint PMF table. And there x and y were not independent.
Thank you, ma'am. Yes.
So, ma'am, quick question in that when z equal to 3 and x plus y equal to 3, right? Can you, do we need to consider the possibilities of, 0 plus 3, meaning x equal to 0 and y equal to 3? And
Yes, so that's what I was saying, that you can see k is not taking value 0. K is what? The values taken by x and y. So when x and y are not 0, how can you take that condition that x is 0 and y is 3? Y is 3 is fine, but x is not taking value 0. That is not in the range.
okay, so k is between 1 and 6.
So you have to check the PMF given to you. It is not always that x and y will take value 0, 1, 2, and 3.
Okay.
That might be different also.
Got it.
Is that actually correct? If we expand the second of the two conditions where the definition of f of x and f of y are given, which is 0 otherwise, what does that otherwise mean? If we expand
Otherwise means that in that cases the probability will become 0.
That's correct.
See, the thing is, okay, if you want to write those cases, suppose here, I'm writing different color. So if you want to write, you can write.
I'm sorry for interrupting. If I can just add one more comment.
Okay.
If you can go back to the question, please, ma'am. If you can go back. Otherwise actually means minus infinity to 0. If I expand otherwise.
Otherwise.
Yes, minus infinity to k to 0. It's 0. And 7 to infinity, it is 0. Is that
Yes.
correct?
So actually, otherwise case includes all those values except
The rest
from
of it.
these values.
This range. That's correct.
Yeah.
Yeah. So as you have correctly, I'm sorry. Go ahead, please.
Okay. So if you want to write this probability, you can write definitely. Okay. But when you write the probability, you can see otherwise case. Okay. In that case, it is 0. So this probability will become 0.
Yeah, in any case, it will
Ultimately,
get, those two terms will get eliminated because of 0.
That's
yes.
correct.
Yeah.
Got
But
it.
if there is a condition where if it says otherwise, equal to something else, then I think we still need to consider these conditions.
Yes, ma'am. For that, we are not considering these two conditions: x is equal to 0, y3, or x3, y0.
So this is the way we solve it. If you want to take all the situation, you can take, but ultimately it is going to be 0, which is already known to us.
Yes,
So
ma'am.
why to do extra work? So
Got
we
it,
have
ma'am.
to see the range. Okay, if you want to write it like this, you can write, but this probability will ultimately become 0.
Yeah, ma'am. In this case, it's fine. But if the problem has a different, if another problem has a different value,
Yes. If
then I
the
think you have to
range
consider.
is different, then you can consider all the cases.
Yeah.
So depending on the question, we have to decide. Any other doubt?
No.
No, ma'am.
Okay, then this one. So here x is following geometric P and y is also following geometric distribution with parameter P, and both are independent random variables, and z is equals to x plus y. Then you have to find fz at point 10. So try to find out the value of fz and 10 and see which option is matching with your correct answer.
C.
C.
Okay, only C or any other option also?
D1.
D. Okay. Any other? So we have to find fz at point 10. Okay. So this is basically probability that z is equals to 10. Again, z is equals to x plus y. So x plus y is equal to 10. Okay. So we have to find we have to see which option is correct. So we will try to write in the same format. Okay. Otherwise, what we will do? We will write all the cases and we'll add and we will then calculate the probability, right? But here we know the distribution. Okay. So we can solve accordingly. So how I can write this term? It is nothing but the summation, okay, of all the cases of joint probability when x is taking value I, okay, and then y will be equal to 10 minus
10 minus
I,
I.
right?
Yes.
And what will be the range of I?
Ma'am, can you please
1 to 10.
take the range in this case?
1 to 10.
1 to 9.
So see, it will be
0
1 to 9. So you should remember the range of x and y. So x and y both are following geometric distribution. Okay, and I've already told you one thing, that if x is following geometric, then
Right.
it will be taking values 1,
1,
2,
2.
3,
Yeah.
4,
0
and
will
so
not
on.
be included. Yeah.
So 0 is not included. So 0 plus 10 is equals to 10. In that case is not there. We have to solve the question according to the PMF given to us, not in general. Okay, so in that case, you can see x is following geometric, it is not taking value 0. So it will start from 1. Okay, and you can see that it cannot go up to 10, because if x is equals to 10, then y needs to be 0 for x plus y should be equal to 10, which is not possible because y is also following geometric, so y can never be 0.
Okay, ma'am.
Yes, ma'am. Yes, yes.
Okay, so that
Yes.
case will not be included. So the range will be starting from 1 and will go up to 9 only. Okay.
And for anything more than 10, y will become negative. That's not even possible. So that we are limiting it to 9.
Sorry, what?
For any value more than 10, at 10, y will become 0. That's not possible. And for any value more than 10, y will become negative. That's also not possible. That's why we are limiting it to 9.
The only thing I don't understand what you are saying, negative. Okay, so see, the sum should be equal to 10. Okay, and it is a discrete case, right? So it will be taking values 1, 2, 3, 4 like this.
Yeah, that's what I said. I said basically that for 10, y will become 0. That's not a possible situation.
Yes,
And for
yes,
any
not
value
possible.
more than 10, y will become negative. That's also not possible. That's why we are limiting the
Yes, yes,
summation limit from 1 to 9.
yes.
Okay.
So now this statement is clear.
Yes, ma'am.
Okay, this is nothing but the general formula. We just have generalized the same thing. So you can see when x plus y were 3 here, what we were adding the joint probabilities for different cases in that particular case when x is plus y is equal to 3. Okay, so the same thing I have written but in like form of I, and we have taken the summation. So again, this is the joint PMF.
And JD
Again, this is the
also
joint
geometric,
PMF.
no? JD is also geometric.
Z is also geometric. Z, that, yeah, I'll have to see the summation of geometric is also geometric or not. I'm not sure right now. So the same thing I have written, okay, the joint probability, and we have taken the summation, and we are ranging the I. Now since x and y are independent, so we can write the joint as the product of marginal. So x is equals to I multiplied by y is equals to 10 minus I. Is it clear?
Yes, ma'am.
Because both are independent. Okay, now we can just solve. So this is the PMF of geometric distribution at point I, and this is also geometric when y is taking value 10 minus I. So summation I going from 1 to 9, and you should remember the formula or the PMF of geometric. It is 1 minus p to the power, here it is I, so it will be I minus 1 into p.
Yes, p.
Okay, and then here it will be 1 minus p, 10 minus I, then minus 1
Minus 1, 1.
into p.
P.
So you can simply solve it. So p and p will be p square. Okay, and then 1 minus p to the power. So plus I minus I will be cancelled out, right? It will become 10 minus 1, and minus 1 will become minus 2. Okay, so it will be p square, and it will become 1 minus p to the power 8. Okay, now you can see in this part I is not there, so we just have to add it 9 times. So it is from 1 to 9, so we will write 9 p square 1 minus p to the power 8. I hope you know this thing. We just have to add this term 9 times, right?
Yes.
So 9 will be there. So 9 into p square 1 minus p to the power 8. So you can see that option number B and option number C will be correct.
Yes, ma'am.
Anything, any question?
Can you scroll down, please? Okay, thank you.
Okay, is it fine for everyone?
Yeah.
Okay, then solve this question. So here x and y are two independent random variables. X is following Bernoulli with parameter 0.4 and y is following Bernoulli with parameter 0.2. And z is again x plus y. So you have to find the value of fz at point 1. This is also similar to the previous questions.
Range of x and y will be considered 0 and 1.
Yes, because x and y are following Bernoulli, so x and y will be taking values 0 and 1 only.
Audible? Hello? Am I
Yes.
audible?
Yes, yes.
In this case, the range of x and y will be taken as 0 and 1, right?
Yes.
Okay.
So here we have to find fz at point 1, which means probability that z is equals to 1. So probability that x plus y is equals to 1, right?
Yes.
Now, since x and y both are taking values 0 and 1 only, okay? So either x is 0 and y is equals to 1, then the summation will be 1, or x is
0.44.
equals to 1 and y is equals to 0. Okay, these cases will be there. Now, since x and y are independent, we can write it. Probability x is equals to 0 multiplied by probability y is equals to 1. And here probability x is equals to 1 multiplied by probability y is equals to 0. Okay. Now tell me what will be the probability y is x is equals to 0?
0.6.
0.6. Is it clear to everyone? How is it 0.6?
Yes.
Because 0 means failure.
Yes. Okay. And it is following Bernoulli with probability of success being 0.4. So the probability for failure will be 0.6 into probability of y is equals to 1.
0.2.
Will be 0.2. It is 0.2. Then when x is 1, it will be 0.4 probability of success. And when y is equals to 0, it will be 0.8. 0.12, 0.32, so 0.44. Okay, is it clear?
Yes, ma'am.
Yes.
Okay, this is the second part of the same question.
Madam, why probability of failure is taken as 0.6?
Yeah. So see, in the question, it is given that X is following Bernoulli with parameter 0.4. So whenever it is written X is following Bernoulli distribution with parameter P, suppose. So P is nothing but the probability of success. So in general, what we do, X takes two values, 0 and 1. Okay. So 1 is what? Success. Okay, and 0 is what? Failure.
Okay.
Okay, so X is 0, which means you have to take the probability of failure, which will be 1 minus P. And X is 1, which means success, so it will be P only.
Okay, madam. Thank you.
Now solve this part.
Bernoulli means so binary values only, 0 and 1. Is it something like that?
Yeah.
Or
So
is it because of success and failure we are going for 0, 1?
sorry, what?
Like
See, binomial is the summation of Bernoulli. So in Bernoulli, we have two types of outcomes. Okay, so one we call as success and another is called as failure. So generally what we do, when success is represented by 1 and failure is represented by 0.
okay.
So in the numerator, we will write the joint probability of X and Z, right?
Yes, ma'am.
And in the denominator, it will be probability Z is equals to 1.
लेकिन मैम इंडिपेंडेंट है तो डायरेक्ट अनकंडीशनल वाला मतलब उससे भी
See, here we are given X given Z, okay? And the independent are X and Y. X and Y are independent, not X and Z.
Okay, ma'am. Sorry.
So how can we find this probability? X is equals to 1 and Z is equals to 1. Anyone?
Success.
Probability of X is equal to 1 or Y is equal to 0. That is the only case that is going to be X is equal to 1 and Z is equal to 1. And
correct.
Going to be intersection, man. Because 0, 1, 1, 0, like those are the two possibilities we have. For
No,
Z
0
equal to
is
1.
not there only.
So among that, we can take only 1, 0 and integrate like it's equal to 1. So that means
We cannot take Y value. We cannot take Y value because
P of X as 1 and Y as 0. Only that will be qualified, right?
See, the variable Z is equals to what? X plus Y, okay? Z is equals to 1, right? And X is also 1. Then definitely Y should be equals to 0.
Yes, ma'am.
So we can simply write this probability as X is equals to 1 and Y is equals to 0.
Yes.
So these two probability will be same. Okay, and we do not know the joint probability mass function of x and z. But in this way, we can calculate it. Okay, so this is the only case when x is 1 and z is also 1.
Yes, ma'am.
So we can simply write it like this. Okay, now it is in the form like it is the joint probability mass function of x and y. And x and y are independent. So now we can write it like this. The probability x is equals to 1 and probability y is equals to 0. We have to use the property of independence. Now we know probability x is equals to 1, right? And probability y is equals to 0. So x is equals to 1 is 0.4, right? And y is equals to 0 was 0.8.
Yes.
And probability z is equals to 1, that we have already calculated in the first part.
0.44.
Okay, so it was 0.44.
लेकिन मैम हमने जेड को क्यों हटा दिया वहां से?
See, we have removed z because z is equals to x plus y. Okay, so z is equals to 1, that is given.
Yes.
And x is also equal to 1, that is also given. Now this condition will only be satisfied when y is equals to 0. So we can say that when x is equals to 1 and y is equals to 0, then only z will be equal to 1. So this probability will be equal to x is equals to 1 and z is equals to 1.
Yes, ma'am.
So we can simply put this value. Now do you understand?
Yes, ma'am, little bit.
If in case you are given the joint PMF, okay, and you have to find the value when z is equals to 1, then how you see? You see in the table the value of x and then value of y, and we see the common part. Okay. If you have solved week 1 questions. So value of z equals to 1 we have already calculated. It is 0.44. Now find this value.
0.73.
0.73.
0.32. On 0.4. Yeah.
So it will be 0.727 something, which is
Round up to
0.73.
0.73.
Okay. So 0.73, option number B will be correct. Is it clear to everyone now?
Yes. अब मुझे कंफ्यूजन यहाँ पे हो रहा था कि मैं हम लोगों ने सिर्फ एक ही बार प्रोबेबिलिटी x इज इक्वल टू 1 लिखा, z में जो 1 था वो कहाँ गया? मैं यहाँ पे कंफ्यूजन हो रहा था कि y इज इक्वल टू 0 तो लिख दिया, लेकिन वहाँ जो 1 है वो नहीं लिखा z का.
So we have replaced it.
It is implied because z equal to x plus y, right? So z
This
is
is
equal
the
to
only condition. Z is equals to 1, x is equals to 1. So y will ultimately be 0 only.
Yes, yes, yeah, you clear.
Okay. So instead of writing z is equal to 1, we can also write y is equals to 0. Okay, and now we know this joint probability. So we can write it like the product of marginal.
Yes.
So these two probability are actually same. So we are just replacing this value to this value.
Okay, ma'am. Okay.
Okay. Okay, now try to curve this.
Ma'am,
Now try to curve this.
ma'am, minimum maximum वाला concept.
Yes, one question is there. try to solve this one first.
A.
Ma'am, A will be the answer.
Okay. So how did you find that A is the answer?
Z will be the Poisson distribution with lambda 30, 10 plus 20.
Yes. So here we are given that X and Y denote the number of customers queries received at two different call centers during 1 hour period. So X is following Poisson with parameter 10 and Y is following Poisson with parameter 20, and both are independent. And Z is defined as X plus Y, which is representing the total number of queries received at both the centers during 1 hour. So we have to find the PMF of Z. So we have already seen this concept. So Z is equals to X plus Y. Okay, so Z will be following Poisson distribution with parameter 10 plus 20, which is equals to 30. Okay, and since it is following Poisson distribution, we already know the PMF, right? So probability is Z, taking value small z, it is e to the power minus lambda. So lambda is what, 30? Then lambda
Yes.
to the power x, if you remember the PMF. So the power is z, okay, divided by z factorial, right? Don't get confused by this
Yes,
small z,
yes,
capital Z. Just go with the notation given to you in the question.
हम क्वेश्चन में फॉर्मूला में x रहता है, लेकिन यहाँ पे z लगा दिया क्योंकि z is equal to x plus y.
Yeah, so this is the value taken by z.
Yeah.
It could be k or r or something else too. Is it clear to everyone?
Yes, ma'am.
This is also based on that concept we have discussed.
A is correct.
Okay, and what about other option?
Ma'am, what is the
Ma'am,
formula?
option B, since it is binomial.
A and C, right?
So why
A-
option B is correct? Whoever is saying B is correct?
Because ma'am, binomial, ma'am, we have only 0 and 1, correct? As a chance of success and failure.
So it is not binomial where we have 0 and 1. That is Bernoulli.
Yes.
Yeah. So like, yeah.
It
So
will be-
because of that, we have two possibility on.
बस
you
इसको
are-
n बार कर दो, बस हो जाएगा, वही बाइनोमियल है.
Okay,
एक
so
बार
that
जब-
is 40. That is 40. That is okay. What about the probability of success?
1/2.
Lambda 1 by lambda 2 plus lambda 1 plus lambda 2. So it will be 10 by 30. So 1 by 3.
Yeah, that is correct. You are saying whoever is saying 1 by 2, why it will be 1 by 2?
Yes, ma'am. I am wrong. I am wrong.
Okay, so it is not always 1 by 2. If you are taking a case of fair coin, then it is 1 by 2. Not always. Generally, we see the examples on coins and die, so that side is 1 by 2, 1 by 6, but it is not always. You have to look in the question. Okay, so
हमने x plus y वाला केस भी जोड़ दिया इसमें 1 by 0.
yeah, it is based on that concept we discussed earlier. Okay, let me show you once again. Okay, this is the concept. Okay, so x
Yes.
was Poisson, y was also following Poisson, and z was Poisson lambda 1 plus lambda 2. And now if x given z, then it will be following binomial with parameter n comma lambda 1 divided by lambda 1 plus lambda 2. And if you have y given z, then it will be lambda 2 in the numerator and lambda 1 plus lambda 2 in the denominator. Okay, so
Yes.
in this way you have to find the probability of success. Okay, in this type of question. Okay, now you look in your question, what is the value of lambda 1 and lambda 2? Okay, so now you can see x, this is lambda 1 actually, this is lambda 2. Okay, so x given z will be 10 divided by 10 plus 20. Okay, so
Yes, ma'am.
x given z is equals to, here z is equals to 40. Okay, there we have n, so we wrote it like n, so here we have 40, so it will be binomial 40 comma 10 divided by 10 plus 20. Okay, which will be 10 by 30, which will ultimately be 1 by 3.
Yeah, अभी clear हो गया.
So option number A is correct. Now we have to see in option number C and D. You just simply have to write the PMF of binomial. So if you have x following, okay, I will not write x, otherwise you might get confused. X, Y, Z are also all three are here. I am writing it as A. Is it okay? Don't get confused with it. Suppose A is a random variable which is following binomial with n comma p. And you have to write the PMF of A. So how we can write? It is n c A we can write. Okay. Then p to the power A. 1 minus p to the power n minus
N
A.
minus A. Yeah.
So this could be anything x, y, z or any variable. Okay, according to that you can do modification in your PMF. So here we have binomial 40 comma 1 by 3. So 40c is x, right? And here you can see that x is taking value z, so it will be 40c 10, right?
C
And
वाला
then c is the combination, okay, not a variable or anything.
yes.
Okay, then probability of success to the power 10. So 1 by 3 to the power 10. 1 minus 1 by 3 to the power 40 minus 10. Okay,
10. Yeah.
so it will be 40. You can write in like this also. This is also the same notation for combination. So 1 by 3 to the power 10. This will be 2 by 3 to the power 4 minus 10, which is 30.
Yes.
So option number C will be correct. Right?
Yes.
Is it clear to everyone?
Yes. Yes. Yes.
So this is probability x is equals to 10 given z is equals to 40. Okay. Now one last question. So x and y are two independent discrete random variables with this CDF, capital Fx and capital Fy respectively. And here z is minimum of x and y. Then you have to check which of the following options are correct. So we have to find the CDF of Z, right? So Fz at small z, which means that probability capital Z is less than or equal to small z, right? This is something we have to find.
Yes, ma'am.
Okay, this is the CDF, not PMF. So now Z is the minimum of X and Y. It is minimum of X and Y that is less than or equal to Z. So may I write it in this way, that 1 minus probability minimum of X comma Y is greater than Z?
Yes, yes, ma'am.
Okay. Now you can see here that if the minimum of two values is greater than some value, then both the values should be greater than the particular value.
Yes, ma'am. Yes, ma'am.
Right? So X will be greater than Z. Also, Y will also be greater than Z.
Yes.
So you can understand it like this, that if I take some values, suppose minimum of 2, 3 is greater than 1. So you can say in 2 and 3, 2 is minimum. And 2 is greater than 1, then 3 will definitely be greater than 1.
Yes.
Right? So both 2 and 3 will be greater than 1 in that case. Okay, same thing I have written here. If the minimum of X and Y is greater than some value, then both the values should be greater than that particular value given to us. Right? Now we are given that X and Y are independent. Okay? X and Y are independent. So again, we can write the joint as the product of marginal. So X greater than Z into probability Y is greater than Z. Right? Because X and Y are independent. Okay, so what options we are given? So you can see this is the option number C. Okay, so option number C is correct.
Yes.
Now we can write.
And A is also correct, I think.
Yes, so option number A. So A is this one, this statement, and the last line is equal to option number C. So these two options will be correct.
Ma'am, the second line, what you wrote now, 1 minus probability of minimum xy greater than z. How this? Can you please explain that?
This is
when minimum probability of minimum xy less than equal to z. So you were telling that xy greater than z. Then 1 minus.
So this is simple. Like whenever you are given x is less than or equal to 2, how we calculate it? 1 minus probability x is greater than 2. Right? So you just assume that at the place of x, we are given minimum of x and y. We just have used the property of probability. Okay?
Okay, okay, ma'am.
Any other question? Any other doubt? Is it clear to everyone?
So can we consider B and B also? B and D.
B and D, C. If you consider this a statement, probability minimum of x and y is less than or equal to z, then we cannot write that both the values will be less than
Correct.
right?
Right.
Okay. So that will not be correct. It will be wrong.
True. Thanks.
Any other doubt?
Ma'am, if probability of minimum xy equal to z.
So then in that case, we write it like this, that if you are given some point z and you are given z plus 1 and you have to find the probability at z. So what you can do, greater than z and minus greater than z plus 1. So you will be left with this probability only. So you can write probability that z is equals to small z. Okay, whatever the value of z is, minimum. So you can write that probability z is greater than small z. You have to minus z is greater than z plus 1, something like this. Or you can take a different case also, like z minus 1, and you subtract z from, you will subtract z minus 1 from z. So that depends. Okay.
Ma'am, one question, ma'am. Here, this joint PMF, okay, we are having in the third step, we have P of x greater than z. That is a joint PMF. How, this is within the P already. This is already within the probability. How can we apply a joint PMF? We can assume actually from there. Actually, how
This
can
is-
derive to the last step? The joint
This
PMF.
is not a joint. This is not joint. This
Yeah,
is
that's
just
not joint.
Yeah.
No, but the next step actually we made it as a joint. Okay, consider as
yes.
a joint. Yeah, that time okay. But from the joint, it is already within the probability. Okay, and x is greater than z and y is greater than z. How can we assume that as a joint PMF? Because earlier I remember, like when we use the function f, okay, and we have x greater than z and y greater than z, then we can actually go to the next step as deriving as a joint PMF. But here within the probability itself, actually, how can we assume it as a joint PMF? Madam? The fourth step to arrive.
See, here you are having two different variables. Whatever values they are taking, that does not matter. So you are giving probability something like this, x and y. Now we are given that x is greater than, suppose, some value a, and y is greater than, suppose, some value b. So this is also a joint PMF. Or you can also write x is less than some value a and y is less than some value b. This is also a joint. And if you write x is equals to a and y is equals to b, this is also joint PMF.
Okay, inside P, whichever actually the two variables separated by
because you are
comma, separated by comma, that we
Yeah.
can consider as a joint.
Yeah, that is joint.
Thanks.
Ma'am, if probability, let's examine probability of minimum 1, 2 is equal to z. So we take all those cases where 1 is minimum, है ना?
In discrete case, you can take it like that. If you are given
Yeah,
four
I'm
of the
talking
values,
about discrete case, and what is the difference in discrete and this CDF and normal
yeah,
both
in
have?
week 2 we have studied discrete only. Yeah, so if you are given a particular value, you can find those cases as we have done for x plus y and or any other function.
But when it is given less than z, then matlab minimum 1, 2 is less than z.
Yeah, so that's what I was writing here. So in that case, if you are suppose this is some value z, okay, not z, k suppose, okay, and this is some value k plus 1, and you have to find probability minimum of x comma y is equals to some value k, right? You want to find this probability. Okay, so how
Okay,
can
yes.
we write that it is minimum of x comma y, okay, greater than or equal to k, minus probability minimum of x comma y greater than or equal to k plus 1. Okay, suppose this is nothing but one variable z. Okay, so z is greater than or equal to k, and this is z is greater than or equal to k minus k plus 1, which means in this case we are adding all the probabilities above k, and in this case k plus 1 we are adding all the probabilities greater than k plus 1, greater than or equal to k plus 1. So when you subtract, okay, this is one line suppose, and this is one line. When you subtract, you will be left with this part only, and you can see it is a discrete case. We have only one point k. There is nothing between k and k plus 1, right? So you will get the probability. So you will get the probability minimum of x comma y is equals to k.
मैम एंड व्हेन नॉट इक्वल टू लेस देन मतलब प्रोबेबिलिटी मिनिमम x comma y less than or equal to k as in the then what we will do?
So that's what we have done. Minimum comma minimum of x comma y is less than or equal to some value. You can find it in this way: 1 minus probability minimum is greater than z, and then you can find the cases, or like this, the joint and then their marginal.
Okay.
Okay. Anything else?
Thank you, ma'am.
Yeah, okay.
Thank you, ma'am. Thanks a lot.
Thank you very much.
Thanks a lot, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Have a good night. Bye.